Hi everyone, my name is Edward and this is Justin, and today we're going to be talking about our final project for this class, for which we built a Rubik's Cube tutor. We initially started out our learning objective as teaching you how to solve a whole Rubik's Cube, but we quickly realized that that was too complex, and so we moved on to just learning the 2 steps to solve one face of a Rubik's Cube. In terms of learner expectations, we want learners to, 1, be able to identify the current state and the next state to solve for. So that's either the white cross or the white corners. 2, identify which tiles need to be fixed. So in this case, maybe there's one green tile on one of the cardinal directions of the cross. And if so, then are any of these tiles in any of the common tricky configurations? 3, recall the set of moves that can be used to solve these tricky configurations. And 4, visualize the results of these moves. In design considerations, we have to think about simplifying the 7-step design process, which is very complex, and trim it down to something that's more manageable. And we also have to represent a 3D object of a cube onto a 2D medium. Finally, the needs that are being addressed in our tutor are 1, the overwhelming complexity of trying to solve a whole Rubik's Cube, and we address this by doing just one face. 2, insufficient guidance through the steps of actually moving the tiles during a step. And so we try to do this by adding visualization and giving hints on the tricky states. And 3, visualizing these tricky states and how they can be solved. For this demo, we'll go through one of the problems that we specified for our tutor. In this problem, we first start with the left-hand panel where we specify the configuration of the cube at the beginning. And then below that, we give some basic explanation about what a white cross looks like and what some white corners look like. So we can see that most of the white face is done here, and all we really need is this last white corner. So the next step to solve this cube is going to be to form the white corners. There's only one tile that is the wrong color right now. And moving on, we kind of ask you to try to identify which tricky case that the cube is currently in. So you can see that the remaining white tile is on the right face of the cube. And so looking down at white corners and checking case 1, case 2, case 3, we can see that case 1 corresponds to this case where the remaining tile is on the right side. So this is case 1. And now we introduce some basic notation for how to mark moves on a cube. And this involves FRULD and a tick mark. Tick mark represents counterclockwise rotation. Otherwise, the letter represents the face to turn clockwise. So seeing the case here is case 1 for white corners. We can see that case 1 for white corners is R tick, D tick, R. And in the remainder of the problems, you can kind of go through and based on this move sequence that we just inputted here, visualize what the cube will look like after each move. So for example, after this R tick move, which means to turn the right face counterclockwise once, the cube will look like this. Then after we do the D-tick move, which means to turn the bottom face counterclockwise, the cube will look like this. And to find this diagram, you would want to look at your answer to the previous diagram and kind of visualize from there. And finally, when we do the last move, which is a clockwise turn of the right face, then the cube will look like this. And we have a complete white face.
In this tutor, we use FRO notation to denote which direction and which face the cube turned. We had to teach the learners this notation, but it may be more visual and natural for learners to describe their solutions in text responses. Our experimental design plan is to build 2 tutors, one with FRO notation and one that does not teach FRO notation, but instead use text input parsing. Next. We got a lot of feedback from our users. Some users wanted more background on the jargon used, again tying in with our FRO issue. And another suggestion was to add a more visual method of solving cubes. Our next step for improvement would be to develop an interactive cube that would change states with each rotation selected. Next. In retrospect, it was difficult to generate cube configurations algorithmically. We had to manually capture each cube image and import it as a JPEG. We also had to do a lot of thinking during the CTA on how to translate a 3D problem to a 2D interface. However, I think we were able to successfully teach our users skills transferable to the real world. Thank you. That's the end of our presentation.